When we're done with this video, we should be able to complete classifying numbers, rational and irrational, classifying numbers, approximating square roots, comparing irrational numbers, and the quiz 2 that I assigned. Let's go. In this video, we're going to learn a little something about the number system. So the number system is basically made up of the real numbers. We're going to start with just real numbers. You're going to learn about imaginary numbers in later classes. Real numbers are made up of two types of numbers, rational numbers and irrational numbers. So far in your math career, you've only worked with rational numbers pretty much. A rational number up at the top is any number that can be written as the quotient of two integers. That is the definition of it. So that means any number that can be written as a fraction. Okay, and we'll take a look at some examples in a second. It includes repeating decimals and all decimals that terminate, that end. Okay, so let's take a look at some examples of rational numbers. So the most common that you started with when you were in like third grade were whole numbers. So just positive integers, essentially, the counting numbers. 0, 1, this is 2, root 4 is 2, 3, 4, 5, right? Any square root of a perfect square is also a rational number. So for instance, the square root of 25 is 5. It's a whole number, okay? Then we expanded to the integers. Integers were the counting numbers, but they're negative counterparts. So for instance, -1, -2, -3, -4, -5, those are integers. Integers also include whole numbers, so the positive ones as well. Now, the other types of rational numbers are things like decimals that end, 4.5, right? It ends. 27/4, okay? That is a fraction, okay? It could also be turned into a decimal. By definition, that is a rational number. -6/7, that's a fraction, the quotient of two integers. By definition, a rational number. 0.3 with this line over it means it's repeating. Any repeating decimal can be written as a fraction. 0.3 repeating is actually 3/9, or more commonly 1/3. All right, if you took 1 and divided by 3 on your calculator, you get 0.333333333. It is a rational number, repeating decimals. So what are the irrational numbers? Irrational numbers is basically the square root of any non-perfect square, okay, or numbers that never terminate. So pi is a number that does not terminate. The supercomputers of the world have tried to calculate pi to its last decimal place, but it's still going. It's just a number that never repeats and never ends, goes on forever. Irrational. The square root of 17. 17 is a non-perfect square. Okay, so 16 is a perfect square, so it would be a rational number, but 17, there are no two numbers that when you multiply them together gives you 17. That is an irrational number. Square root of 2. 2 is not a perfect square. There's no two numbers that when you multiply them together give you 2. Okay, non-perfect square. -√11, again, non-perfect square. There's no two numbers when you multiply them together give you 11. We can estimate, but we can't tell you the exact value. Okay, the perfect squares were those numbers, that I had you memorize, these perfect squares. 4, 9, 16, 25, 36, 49, 64, 81. These are the perfect squares. You could keep going. Okay, there's an infinite number of perfect squares. Okay, so let's look at trying to find the approximate values of some square roots, okay? You don't have a calculator, you're trying to figure out about what the value of root 27 is. So what we have to think about is this lies in between what two perfect squares? Well, it's between the square root of 25 and the square root of 36, right? This is 5, this is 6. So root 27 is going to be right about here. So there are, let's see, 25 to 36. There's 11 units in between them. This is 2, right? This is 2 units from 25. 2 units from 25. So 2/11 of the way, well, that's about 0.2. So this is going to be 5 plus 0.2. 5.2. That'd be a good approximation. Okay. Let's take a look at the square root of 12. All right, so what two perfect squares does that lie in between? How about root 9 and root 16? So let's see, 12, 10, 11, 12. Root 12 would be right about here, so that's 3 units. and 12 to 16 would be 4 units. So it's about halfway, a little less. So this is 3, this is 4. So it's about 3.5, a little less, I would say. So possibly about 3.4, between 3.4 and 3.5. Okay, and I would just go to the nearest tenth. The square root of 120. So that's going to be in between, well, it's really close to 121, which is 11. Okay, and there's 100. Square root of 100 is 10. So root 120 is somewhere between 10 and 11. All right, it's right here. It's 1 unit away from 11. So I'm going to call that, well, let's see, 10.9. It's probably even 10.95 if you want to get really close. Because if there's 21 units and we are 20 units away, that's a really, really small amount, right? Out of the 21 units, we're 20 away. I'd say 10.95 most likely. All right, root 40. So let's see, root 36 comes right before root 40, and then we have root 49. So root 40 would be 4 units away, and then 9 units away. Okay, so the value of this is 6, the value of this is 7. So we're going to have 6, and let's see, that's about a third of the way. So I probably call that about 6.3. So we're just trying to estimate. Okay. You're going to use that knowledge to be able to complete the last 2 sections in Khan Academy.